Hey guys, want to do a video on graphing trig functions. So let's start with just the basic sine and cosine graph. Uh, Notice this one I did in degrees. So every 90 degrees is what I call a critical point. And then here I did cosine and radians. So 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Okay, so remember sine graph. Sine graph is going to start in the middle. Sine of 0 degrees is 0. Sine of 90 degrees is 1. Sine of 180 is 0. Sine of 270, -1. But there's just like a little pattern. You don't have to check every time. Oh, what's the sine of 450? Just middle, top, middle, bottom, middle, top, middle, bottom. Okay, and then that pattern would continue. So here is your sine graph. And then cosine, this guy, cosine of 0 degrees is 1. And then that pattern is going to continue again. So top, middle, bottom, middle, top, middle, bottom, da 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 da. So here's your cosine graph. Okay, so these are just the basic sine and cosine graphs. Um, you might do one or two of those on your assignments, but these can get have some different transformations to them. So scribble this down for me here. You're taking notes or something. So this is everything that could be shifted or transformed on these sine or cosine graphs. I put cosine right here, but it doesn't matter if it's sine or cosine. So this C value, that is the midline, or some textbooks will use this word sinusoidal axis. It's like the middle of the graph. So in these pictures, the x-axis would be the sinusoidal axis. This A value, that is the amplitude. Okay, and that's going to be like the height of the graph. The B value, that is going to affect the period. Okay, um, what I mean by that, here I would say sine completes one cycle in 360 degrees, because that's how long it takes before it starts to repeat itself. So notice it goes from the middle going up back to the middle going up after 360 degrees. Cosine, same story. From the top back up to the top takes 2 pi, okay, or 360 degrees. So that's one cycle, or that's also known as the period of the graph. So this B value affects the period. I'll do an example here in a minute, but it's either going to be 360 divided by B if you're working in degrees, or if you're doing radians, we're going to use that guy. Okay, and then the D value, that is what they call a phase shift, and that's going to take those graphs and basically shift them to the left or to the right. Okay, so I'm going to do one example with these three guys right here, and then I'll do another video that involves this guy. So here, let me erase this, and let's check out that one example. Let's see, 2 cosine 4 theta minus 1. Okay, so let's go through here. Let's pick out the sinusoidal axis, the amplitude, the B value, all that good stuff. So the C value, in this case, that's this -1 right here. I know when I wrote it earlier, I wrote this, right, where I put the C value at the front, but those could be moved around. Okay, so my C value is -1. The amplitude, or the A value, that's this the coefficient of your trig function, so that's 2. And then the B value is equal to 4. So when you guys are doing these, as soon as you find the B value, here's what I want you to do. Use those little equations. I'm going to do this one in degrees, and then I'll go back and I'll do it in radians also. So the period is equal to 360 divided by 4, which is 90. Okay, so it's going to complete one cycle in 90 degrees. And then also do this. CP stands for critical points every, and whatever you get for this guy, divide that by 4. Okay, which in this case, what is that? 22.5 degrees. Okay, so here's what the graph of this thing would look like. Notice the C value is -1, so that's the new middle of the graph. So here's -1. Some people like to put a dotted line right here. You don't have to, but that way they know, oh, that's the new middle of my graph. Amplitude is 2. So from -1, I'm going to go up 2. So 1, 2, and I'm also going to go down 2. So the highest this graph will go is up to 1. The lowest it'll go is down to -3. And then that's it for those two guys. And then let's talk about this. The reason I do this part right here, divided by 4, it gives me these critical points. So what I'm going to do with that, every 22.5 degrees, I'm going to put on the x-axis here. 67.5, and then 90 would be next. And then you could keep going, right? 12.5. And it goes back this way. Okay, so those represent all my critical points that I got from this guy right here. And then last thing you need to take care of, it's a cosine graph. Remember, cosine starts up top. So that's going to look like, I don't know where my blue marker went, but so cosine would start here and then go to the middle. Remember, the middle is at -1, not my x-axis. And then it'd go down to your lowest range value, and then back to the middle, then back to the top, then back to the middle. Okay, so here's what this graph would look like. Oh, shoot. Okay, something like that. When you're doing these guys, just remember, don't do like, these aren't like rugged, okay? You want them nice and curvy, okay? So, oh, wait, one sec. I wanted to do radians with this also. So if I was doing this in radians, nothing would change except for this part right here. Period would be 2 pi divided by 4, which is simplifies it pi by 2. I would still do this. Critical points every pi over 2 divided by 4, which works out to pi over 8. So the only thing that would change is here. I'm going to come in here and I'm just going to put these critical points every pi over 8. So watch how I do this. 1 pi over 8, 2 pi over 8, 3 pi over 8. This would be 4 pi over 8, 5 pi over 8, 6 pi over 8. Keep going and going. And then once you do that, so it's easy to count like that, and then once you do that, just go back and reduce to anything that you can. Like 2 pi over 8 is pi over 4, 4 pi over 8, pi over 2. Okay, there you go. Hope that helps. Peace out, my homies.